Hello and welcome back. My name is Corey. I guess you're my rubber ducks, and we are continuing this series where we are creating a programming language from scratch. That's right. Just C++, a few tools, an editor, Vim. Um, yeah. If we don't write it, it doesn't exist in the language. We are on episode 33 now, and we've done a lot of work. I went back and looked at the list. Well, I'm going to do something today that I have not done in any of the other languages that I've written, and that is we want to add support for our string variables to, our string literals to be saved somewhere, saved away. What do I mean by that? Well, I think demonstrating it is the best way to show you. Um, there is our editor, and I always say nothing up my sleeves, right? I haven't pre-done any of this. Well, and I definitely haven't even written this before. Whereas I have at least written an implementation of a programming language. I haven't done it on this one. I mean, I haven't done this particular feature. So we're going to, wasn't sure why it wasn't showing up, git log. The very last commit I did was episode 32, the updating the docs. So there's that there. If I say git status, haven't done a thing. And we're going to start off by looking at the test code. Yeah, that's the easiest thing to say. And we have our print, but where I'm going to go is something like this right here. Let's go for this one, this P4. And I'm going to see out p4.get bytecode, not opcode. Get bytecode. And on the right hand side, let's get our compile happening. It should be make test watch. Like I've done this a million times. What am I getting wrong? Oh, it should be dump bytecode. Dump bytecode. We're off to a great start so far, aren't we? Okay, now what's going to happen in this little loop is we've got our our null val, right? Whatever. And when we get to this, the string here, well, this is a loop. There's going to be a loop in here, and the jump if false to 31, that would be the exit. So if it's not false, we just keep going, and it's going to create a string on the stack. And then we jump back to 7, and we process through it however many times. So this is going to create a string 10 times, because this loop is this one right here. I is equal to 0, I is... oh, this was our false case, but when it's less than 10, whatever, it's going to do it a lot of times. And I'll still stick with this one just because I want to see some code. I don't care that that we're on the one where it tests false. But we don't want it to do this. We don't want it to create a new string on the stack each time. So one of the things that we can do is actually an optimization that C and C++ does, right? They take your text and put it somewhere up in the... is it in the data section? I always forget. Basically, Corey, you should have looked that up. I know, it's been 20 years since I studied that. But anyway, they put it in a protected location, right, so that it can't be written to, but they only do it once, and then they just reference that. And that's what we want to do. But for our case, what does that look like? We don't have this kind of section somewhere else that we can use. But what we do have is we can use the stack and just create it once when we enter into the scope for that string. So that's what we're going to do. Now, in order to do this, we've got to modify. Well, think of it like this. It's going to work very similarly to all of the collect identifiers, you know, where we just start off with the first node and say, hey, collect all the identifiers into this container. And they say, okay, I'll collect all of them. And if they have a left-hand side and a right-hand side, they tell each one of those, hey, collect all the identifiers. So if it has a variable name in there, it will go into this collection. That's what we need to do, but for strings. So we're going to follow the same, I want to say procedure, but it is very similar. Okay, so let's go into our include for computed expression. And we should have, don't we have a collect? Gather? I don't remember. Find? Corey, you really should have looked this up before we started. Oh, it's in the AST nodes. Sorry, that's why. Edit the include AST node. Yes. And it was collect identifiers. I wasn't too far wrong. And yank 6. And now we're going to do compile a list of all string constants in the scope. And instead of collect identifiers, it will be collect strings. Sure. All right. First one is easy. Notice that whatever we're collecting is going to be in the program. Well, let's go ahead and continue with this train of thought. We need to we need to edit the source for the AST node. And our collect identifiers, by default, we're going to have the exact same thing here, except it's going to be collect strings and nothing. Okay. That is, we're giving it a default behavior of don't do anything. Okay, that's fine. Now everything's compiling again. We're happy. We need to edit the program.hpp. The reason is just like, if I can find it, the stack of mappings of identifiers to their stack locations, we need the exact same thing, but for strings. Okay, so stack of mappings of strings to their locations, and we'll just a string to some location. And instead of identifier stack, we will call this the string stack, just so that it's hard to pronounce. Okay, so we've added that to the program. Now we need to edit the source of our program.cpp. And the reason is for the, just like we had to prepare the identifier stack, we have to prepare the string mapping stack. And string stack, there we go. And gather all of the strings in the okay, that's fine. You should say, Corey, you should have just copied. I know. I was thinking about something else. That happens. Collect strings. Star this. Okay. I'm just doing a quick little glance through, and so far nothing's changed. Well, things are about to change. So, for our strings, what do we do? We're going to have to do this as well. Reserve space on the stack for each variable. Okay, so what it is for this one, we didn't care what the value was. We just pushed a null, and it was fine. But what we want to do is we want to have, if there's an A and a B, it's going to say, push a null, push a null. Okay, that's fine. But if we have the string of the character hello world, then we want it to be just like it was the opcode null val for push a null. Then we want it to be the opcode for a string and whatever's in the string. That's what we want to happen. So we can't do it in exactly the same way. What we were doing before was using a ranged for where we went through each item in the stack. And you know what? I just don't remember what this is. So C++ ranged for on a map. What does it return? Is it a pair? Just give me a documentation link, please. Okay, fine. I'll go to the first loop. The first link. Yeah, the range declaration of name variable is type is the type of the element of the sequence represented by the range expression. Yeah, but I know that. What I want to know is the vector is easy. What is it for a map? There. Int to an int. No, not going to do that. Not going to do that. Oh, it's a dot first and dot second. That's all I needed to know. It's a pair. Okay. So, what I can do here is reserve spaces on the stack for string. Oh, but this is a little bit more complicated. So this is going to be where the string number, or the string contents is going to have the number 1, or the string is going to have the number 2. The problem is now I need to go through those in order. So I basically need a reverse mapping of the strings. Find the string that has the value of 1. Okay. So that's going to be something like auto I is equal to 0, I is less than string stack dot back dot size plus I. That's fine. And for each one, we need I'm not going to do that. Say, Corey, are you arguing with yourself? Yes, I am. That's fine. What am I looking for? C++, and we're going to say map search for value. Is it dot find? I don't want a key. I want a Nope, that's not it. Okay. Fine, I'll go with the first one. Hate doing this stuff. Especially... There's got to be a way to do this with the C++ algorithms. There's got to be. I mean, we can do it, but there's got to be. Okay. All right, so for the first number, what we're going to do is we're going to auto we're going to go through, and if I is equal to item dot first, then, and this is the hard part, we need to do a computed expression string, and we're going to feed it a wait, that would be second. You know what? I know of a faster way. Say, Corey, why do you keep stopping and talking to yourself? Well, the problem is I have not programmed in C++ in a very long time. And what I And so I know things are possible, and I'm like, but I don't remember how to do it off the top of my head. So what I want is to create a vector. Just show me the constructor. There we go. The size. Sure. Let's see if this works. So rather than what I was about to do, I'm going to say a vector of strings and we'll call this string literals with a size of that. So string literals is now a vector of strings, each one having that. Okay, now for auto ampersand item of this string stack dot back. So go through it. And what are we going to do? We're just going to say the string literals sub item dot second, because that should be a number, is equal to item dot first. Easy enough. And now for auto ampersand literal in string literals, what do I need to do? I need to do a computed expression string made up of that literal, and then I'm going to call compile, giving it the, well, I'm not going to call compile. We'll get to that in just a moment. I'm going to call a new function called compile literal and give it program. Say this doesn't exist yet. I know it doesn't. We're about to make it. All right. And now I can get rid of all that junk. So what is the goal here? What we're trying to do is, first of all, just get them in order, because we need to pop them onto the stack in order. And yes, we need to pop them onto the stack in order, and then go through that list in order, and for each one compile the literal, so it will pop it onto the stack. That's the goal. Again, what is compile literal? We're about to write it. So it should give us an example of, well, it doesn't know what vid is. Doesn't know what a computed expression string is. That is a shame. So it doesn't know what program is. I know. We're inside the program, so it should be star this. And it's not a pointer, so it should just be a period. So used to dealing with pointers. Has no member named compile literal. Okay, we're to where we want it to be. So do I have, I don't have the AST node or a computed expression. I don't have that open, so we're going to open it. The source of computed expression string. There we go. And what did I want it to be? Compile literal. So far, I shouldn't be putting it here. The reason is, so let's create an AST node string. AST node string. Yeah, because that's where we do the compile. Okay. AST node string, I need to give it a location though, because an AST node requires a location. So, should be able to do that. Doesn't know what an AST node string is. That's because there. Should now not know what a compile literal is. Okay, but it took the constructor, so that's a small victory. So this is going to be our include AST node string. There we go. And we're going to make this, I don't think it needs to be a virtual. Watch, it probably does. Avoid compile literal. That takes a Tang program ampersand program const. And now it's going to complain that it's not defined, but that's okay because we're about to define it. Source AST node string. And now this is compile. What did I call it? Compile literal. Compile literal. Now right now, this should compile. We'll see the code, but it won't change anything. We're not getting the compile. Why are we not getting the compile in there? What I'm expecting to see is we've got our, well, let's just go back to 1. There we go. So we are printing out this P4. So we've got an I and an A. So that is this one, I and then A. And, oh, why is it not doing anything? Because we never told it how to collect that value. That's right. Okay, so now we've got to do a little bit of work with the AST nodes. Are you ready for this? So I'm just going to very temporarily, normally I wouldn't do it like this. I wouldn't open 15 windows, but I am at this exact moment. And Tang, and for the, yeah, we'll do it in the includes. And what I'm just going to do is a git grep -in, and what is it? Collect identifiers. Okay, so everything that has a collect identifiers, every one of those will also need the collect strings. That works almost the same as collect identifiers, but it's just collect strings instead. All right, so let's start. I think the easiest way is to just reopen it with the includes of AST node everything. So this is 9 is the basic one. Collect strings is what we want. And now, if we collect identifiers, we also need to collect strings, and then add the override. Okay, so this is for the string. We definitely need it here. Collect strings, okay. Wait, but this is for the, yep, we do need it here. This is in the node block, need it there. We don't need it for the Boolean. Do we need it for the cast? No, we do not. Do we need it for the do while? Yes, we do. Do we need it for the float? No, we do not. For the for? Yes, we do. Do we need it for the identifier? No, we don't, because an identifier can't be a string. So even though it has collect identifiers, it doesn't need to collect strings. What about the if-else? We do. Integer? Nope. A print? Yes. The unary? Yes, we do. The while? Yes. Okay, that's all of them. Now we need to do the same thing, but for the source files. So again, AST node and just open them all. All right, so what's it going to look like for the identifiers? Is that for the strings? What's the fastest way? Say, Corey, that wasn't that fast. I know it wasn't. That was for the assign. For the string, compile literal. Oh, sorry. Collect strings is going to be what should it look like? Let's go to the identifier. That's number 12. Yeah, 12 and then 14. Okay, so B12. Oh, no. Identifier is 10. B10. So the collect identifiers, what does it look like? It looks like this right here. We're going to steal it, and I think I said 14. Yep. There we go. There. I wanted to keep the LHS and RHS. So what I'm going to do with this is something I'm just going to use in a moment. Collect identifiers, excuse me, this is a string, and we're saying identifiers is equal to the stack back if, and it's this arrow val. So I'm saying if I'm not in the vector already, then set my name to be the identifier.size. So the first one that it finds will have a size of 1, the second one size of 2, third one a size, I mean, not size of 3, it'll be a 3. And again, it's going into a map. So that's what it's, this is the only one that has to do this kind of collection, because a string is the only one that has a string literal. Okay. Now, so D4. Now let's keep going. For the identifier, it does not need 1. Integer does not need it. AST node, we've already written it. The do while. There we go. And this should be do while. And it should be condition encode block. All right, float does not need it. The for does. For, and it's initialization, condition, increment, code block. There we go. So The if else definitely needs it. And we need it for condition, then block, and if this else block. Okay. Did that give me a compile error? You know what? We'll fix it later. The print definitely needs it. And I've closed it. There we go. Collect strings. The unary. There we go. And the while will definitely need it. Except it needs it on condition and code block. The block needs it. This one's different anyway, so we're going to have to grab it like that. Instead of collect identifiers, collect strings and collect strings. Binary doesn't need it. Oh wait, yes it does. Edit, what were we on? We were on source AST node binary. Strings, strings, strings. Okay. That should have been all of them. Now let's fix our compile issue. So in source AST node string, of all the places, line 61. Okay, what is it not like? Collect strings. String stack, and let's just call it strings. All right, so that was a lot of back and forth. Again, this was a refactoring one, and looky here. Now we've got we had two variables, a and I, right? And there we go. That was the a, that's the I, and then string is this here. Okay, so we know that we created one. That's good. Now what? Well, we need to use it. So we're already in the file that we need to be in. So this is compiling our literal. This is what created spot 2 here, string that. So our compile now, we no longer want it to do all of this compiling. Rather, we want it to pull from the memory. So for reference, I'm going to open up the source AST node identifier, because its compile is more what we need here. Um, 10. Oh, no, that's the identifier. Okay. And this is just to get some separation mentally. All right, so instead of identifier, yes. Strings. Strings. And this should be string stack. So now what it's saying to do is, so get the string stack, the topmost one. And again, why are we using a stack? Because when we need to have functions, right? And we go into a function, it has an entirely different environment of variables, of what's the name I'm trying to say? Of brain just shut off. It has an entirely different set of variables, yeah, and potentially strings. So, okay. And he said we could be really super smart and try to make every possible string identifier to be here, but I'm not doing that. I'm just, we'll go with this solution. It's a minor inefficiency to make all of the code consistent. So now we're saying, does the string exist in the set of strings? If so, peek at its location. Else, just put a null on there. Should never happen, but if it does, and then we can do away. Nope. With the rest. Now I'm going to compile this. We're going to see if this works. Did we break anything? It's possible. Okay, it failed. Okay. Do you know why it failed? I do. I just saw it. So here's the command. Instead of the string dash, that is what used to be here, right after the jump false, it's peek, but it's peeking 0, and 0 is at memory location A. So instead of it being strings of that, we need it to be plus program dot identifier stack dot back dot size. So what it's saying is, like, however many identifiers are supposed to be there, skip past all of those and then do the string val. So let's see if that is going to be identify. Okay, this is a spelling issue and I'm not seeing it. Oh, identifier. Identifier. There we go, one extra parenthesis. And all of our tests are passing. And we can see here that what was supposed to happen did indeed happen. That is, we peak at 2. So 0 is the A, 1 is the I guess it was, and then 2 is that. And now we only create a string once. And so let's do the test one. Looking for cout. There was one where we did, I'm just going to have to search for it. So there's a lot of hello worlds. Yes, but there's one where we had 3 values right there. And so it's 10. Just because, again, I want to see it. There's no variables here. It was just hello, space, and world as 3 literals. And then we peak 0, peak 1, add them. Peak 2, add it. Yep, that's how it works. And with that, it's a very small thing, but that is an improvement to our language. And hey, I wanted to write something that I hadn't written before on this. Well, I've done that a couple times, but it needed to be done. All right, so let's edit now to wrap things up. We've got our include, Tang, and the string literal on the stack. I didn't know that that was the next thing on the list. Do I have... I was thinking about doing the ternary operator next. But I'm not sure between that and the function declaration. The function declaration is actually pretty difficult. We'll think about it. We'll see. And now, oh boy, it's a big diff. And in the meantime, I'm going to do my standard make clean, make test just from scratch, make sure everything compiles while I'm looking over the code. So far everything looks correct. As part of my visual comparison, I'm making sure that I always say collect strings in the green. Collect strings, collect strings. Because I was copying and pasting, and sometimes I'll make a mistake. Okay. Everything seems to be in order, so one more time was I just git commit dash A and what do we say? By putting string literals on the stack. Only once. And by, instead of by putting, it should be by initializing string literals onto the stack only once. I think I like that better. And now we need to say remove the docs, do our doxygen generation. There we go. And of course, for our classes, we didn't add anything, but other than we know our string will have an additional collect identifiers that only exists. Not collect identifiers, collect strings. Sorry. Collect strings. Compile literal. Why is that not clickable? Did I not give it a... That's why we check these things. So it's our include AST node string. We need to give it a description. So what is this going to do? Source AST node, not source, include. Wait a second. Okay, sorry. I just realized this one right here at param indent the dump. Okay, that's fine. And at return as a string. Okay, that's fine. Same thing with this. We need at param program. Bytecode. There we go. And collect identifiers and collect strings. Okay, now that I've done that, I was putting this on compile literal, which should borrow off of compile. Okay. Let's do this again. I guarantee you there's someone out there who has known all this time that I was missing some stuff and just has never said anything. Okay, so I have a description here. And now if I go back to AST node, I should have the parameters listed that were not listed before. Like indent. Okay. That's fine. And that's just adding a few things. Okay, so for episode, and here we are, never know what episode I'm on. Episode 33. Yeah, just making sure I got everything before I do the tag. All right, it is live. And of course, always like to check out. Yep, we've hit the 4,000 line mark of just code, 1,500 lines of comments. That's good. I would have preferred to have had probably a bit more in the comments section, but well, this is where we are. And the tests take up so much space with almost no comments whatsoever. So that skews it a little bit. But having said that, we have made good progress. And so that puts us, we now have just a little bitty optimization in runtime. But hey, we got through it. And so what's going to be next? We know we need to add ternary expressions there, but functions, I would love to get functions. If we do that, we'll have recursion, and that might have to pull this up. Can I get to it quickly? If we look at the website and the example I give, now we don't have, in our program, we don't have the idea of comments yet. We could add that. But if we add functions, what it looks like everything else would work. So in order to have this, all that we got to do, comments maybe, and functions. That'd be pretty good. Oh wait, I'm sorry, it was I wasn't even showing it. There we go. Comments and a function, and our Fibonacci example code would work. And in fact, it should work. I haven't tried it yet, but we're close, so close. Having said all that, you know what? Hey, it's getting late. Thank you for joining me on the journey, and hope you had some fun. Thanks. Have a great day, and bye.